This question belongs to compiler design subject and was asked in GATE CSE 1991. And the topic name is Parsers. So the question states, choose the correct alternatives, more than one may be correct, and write the corresponding letters only. Indicate all the true statements among the following. Recursive descent parser cannot be used for grammar with left recursion. The immediate form for representing expression which is best suited for code optimization is postfix form. A programming language not supporting either recursion or pointer type does not need the support for dynamic memory allocation. Although C does not support call by name parameter passing, the effect can be correctly simulated in C. No feature of Pascal typing violates strong typing in Pascal. So let us see all the options one by one. So what is a recursive descent parser? A recursive descent parser is a top-down parser. Top-down parser. So what it does, it start with the terminal and it start with the non-terminal and move to the terminals down the tree. But there is an issue. If we have left recursive grammar like this, E implies E plus T or T implies T star F or F implies ID, then before giving this grammar to the recursive descent parser, we must remove the left recursion. If we do not remove left recursion, then what happens? Here you can see E and E, this is left recursion, T and T, this is left recursion. If we do not remove this left recursion, then we will get an infinite loop if we want to generate a string or if we want to verify a string. So recursive descent parser cannot be used for grammar with left recursion, yes, as it may fall in infinite loop. Now let us see what option B states. Option B says that the immediate form for representing expressions which are best suited for code optimization is postfix form. So during compilation we have various steps like lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generation, code optimization, and code generation. But this intermediate code can be of various forms, like we can have three address code, we can have directed acyclic graph representation, or we can have postfix representation, and many more. Before this code optimization, it is saying, is postfix the best form for code optimization? No, this is not true, as postfix is not the best form. We can have DAG as well as three address code also, they will be equally optimized. So option B is false. Now let us see option C. Option C states that a programming language not supporting either recursion or pointer type does not need the support of dynamic memory allocation. So dynamic memory allocation is done in heap. But if we do not have pointers and if we do not have recursion, then assume the languages like Java, object-oriented language. Here we need to create objects. Yes, we need to create objects. Let us suppose it do not have recursion, it do not have pointers. But still objects are created in heap. So thus, and heap has dynamic memory allocation. Thus, for these objects, we need heap. And even for dynamic structures like trees can also be present in Java. For trees, we need this dynamic memory allocation. For linked list, we need dynamic memory allocation. So we basically need the dynamic memory allocation. So option C is also false. Now let us see option D. So option D states that although C does not support call by name parameter passing, the effect can be correctly simulated in C. Let us suppose we have a function fun and it has two parameters a and b. And here in this function, we are using somewhere a and somewhere b. Now what happens in call by name is, let us suppose we call this function fun with 3 plus 2 and 4 plus 3. So what we will do, we will just substitute 3 plus 2 over here in entire code, and in place of b we will write 4 plus 3. So this is called as call by name. But C do not have call by name. So how can we simulate this? So we can easily simulate this by using macro substitution. What is macro substitution? You might have seen we have hash define statements. So we will define hash define. We will define a to be 3 plus 2 and hash define B to be 4 plus 3. And during the lexical analysis phase of compilation, what we will do, we will just put 3 plus 2 in all places of A and 4 plus 3 in all places of B. So it can be easily simulated. Thus option D is also true. Now let us see option E. Option E states that, let me first clear these things out. So option E states, no feature of Pascal typing violates strong typing in Pascal. So for this, you can refer to this statement. This has been taken from Stack Overflow. So it states, a statistically typed language has a type system which is checked at compile time by the implementation. So statically, there are two types. We can have static typing or dynamic typing. Dynamic typing means we do not need to refer to the type. Like in Python, we just write a equals to 5. Or we can also have a equals to Vivek or something like that. A equals to gate. This is dynamic typing, as we are not specifying the type of A during writing the code. Only in the runtime the type would be specified. And in static typing, we need to write the type. We need to do int A equals to 5. So this is static typing. So a static type language has a type system which is checked at compile time, but by the implementation. Let me first increase the font a bit. Yeah. Now, in strong type language, it is not possible for the programmer to work around the restriction imposed by this type system. So these are strong type language. Now it is asking about Pascal. But Pascal was intended to be strong type, but an oversight in the design unchecked variant record. This is this feature due to which it is a weak type language and it's not a strong type language. So option E is also false. So answer is option A and option D are true.